Module 6, Lecture A, String Operations. By the end of this lecture, you will be able to access and slice substrings using string indexing and slicing syntax. Use common string methods to change case, strip whitespace, and search within text. And combine strings and variables to build readable messages. String indexing basics. Index positions explained. Indexing in text means assigning a position to each character, like numbered seats in a theater. In programming, these positions usually start at 0, so the first character is at index 0, the second at 1, and so on. This zero-based system may feel unusual if you are used to starting from 1, but it simply measures how far each character is from the start of the text. Understanding this idea is essential, because many operations on text rely on using these index positions correctly. When working with a short piece of text, such as a name or a button label, each character is assigned an index starting at 0 and going up to 1 less than the total number of characters. The first character has index 0, the second has index 1, and so on. This zero-based indexing is consistent for any string, whether it is a product code or a word like hello. Mapping characters to these index positions lets you precisely locate parts of the string, which is essential for slicing out substrings or searching for patterns. Index positions in a string are important because they determine how you interpret and process the data. For example, the first character in a survey response might indicate a category, while the remaining characters hold details. Or the first 19 characters in a log entry might store a timestamp. When these positions are stable, you can reliably choose which parts of the text to read or ignore. However, if the content changes and shifts these positions, it can affect how your operations work. So you must be aware of how string length and structure influence index locations. Python code index positions explained. To understand string index positions, imagine a simple name written as a row of characters. Each character in the name is matched with a number that shows its position, starting from 0 instead of 1. This is called zero-based indexing, and it means the first character has index 0, the next has index 1, and so on. By lining up the characters with these index numbers, beginners can clearly see how each position in the name connects to its index in the string. This comment explains that the current task can be completed using only the standard library, so no extra libraries need to be installed. It serves as a reminder to developers that if future changes require additional tools, they should ensure those dependencies are installed. For now, it clarifies that everything needed is already available and no further setup is required. We begin by creating a simple text value that contains the word hello, which we treat as an example of a first name. This basic string lets us clearly show how indexing works in Python. By working with this short piece of text, we can focus on how to access each individual character. This forms the foundation for later steps, where we match each character to its position in the string. We begin by displaying the text stored in the name variable so learners can see the full sequence of characters at once. This visual reference helps them understand how each character lines up with its position in the string. By seeing the entire string, it becomes easier to connect each index value to the character it represents. We use the word hello and write out the words 0, 1, 2, 3, and 4, spaced so that each number sits under a specific letter. Each number represents the index position of that letter, starting from 0. This visual alignment shows that H is at index 0, E is at index 1, and so on. It helps learners understand zero-based indexing by clearly matching each character with its position in the word. This line of code prints each character of the text with spaces inserted between them. It uses a method that joins the characters with 2 spaces, so they appear spread out. This spacing visually lines up the characters with their index positions. As a result, learners can more easily see which character corresponds to each index in the string. We now print an index guide that lines up each index number directly under its matching character in the string. This visual layout helps you clearly see how every character is associated with a specific position. It emphasizes the idea of zero-based indexing by showing that counting starts at 0, not 1. By comparing the characters with their index numbers, you can better understand how to access each character in the string. This example shows how zero-based indexing works in Python by accessing the first character of a string using an index of 0. In Python, the first position in a string is always at index 0, not 1. The program then prints this character together with a short message to make clear which character was selected and which index was used to access it. In this example, we access the second character of a text value by using index 1. Python counts positions starting from 0, so the first character is at index 0 and the second is at index 1. We then display this character together with a short message that identifies which character was selected and the index used to retrieve it. This example shows how zero-based indexing works in Python by accessing the last character of a 5-letter string using index 4. The first character is at index 0, so the fifth and final character is at index 4. When we print this character, it appears as the 5th character in the sequence, reinforcing that positions start counting from 0 rather than 1. This script uses the word hello to demonstrate how string indexing works in Python. It shows each character lined up with its zero-based index so you can clearly see which number matches each letter. The script then accesses and prints specific characters, such as the first, second, and last ones, using their index positions. Overall, it reinforces the idea of zero-based indexing by directly connecting each character in the string to its index. Using negative indexes. Negative indexes let you access characters in a string starting from the end, with -1 referring to the last character. This is especially useful when you care about the ending part of a text, such as a file extension or the final digits of an ID. Using negative positions means you do not need to know or calculate the total length of the string. As a result, working with the end of a string becomes simpler and more intuitive. When working with negative indexes in a string, imagine each character having both a forward and a backward position. Counting forward starts at 0 for the first character and increases to the right. while counting backward starts at -1 for the last character and decreases to the left. This dual labeling means you can refer to any character from either direction, depending on whether you want to focus on the start or the end of the text. In particular, the last character is always at position -1, no matter how long the string is. Negative indexes are especially helpful when slicing strings because they let you define ranges starting from the end. For example, if the last 3 characters of a product code indicate a region, you can access them directly without knowing the full length of the code. This makes your logic simpler and keeps your attention on the important part at the end of the string. With practice, thinking from both the beginning and the end of a string makes your text handling more efficient and expressive. Python code using negative indexes. This section explains how to access characters in a sequence using negative index positions. Negative indexes let you read characters from the end, so you can get the last characters without first counting the total length. You should compare the characters you'll get with positive indexes to those from negative indexes to see that they refer to the same positions from opposite directions. If any extra software is required, you may need to install the appropriate library beforehand. Imagine we have a variable that stores a typical file name, such as a report ending with a final version in PDF format. We use this example to show how negative indexing works in Python. With negative indexing, we can access parts of the string from the end, which makes it easy to grab the file extension or other segments. This approach lets us work with specific pieces of the file name without first counting its total length. We begin by printing the full file name so we can see the original string before making any changes. This gives us a clear reference for the data we are about to work with. By viewing the file name first, we maintain context and can better understand and verify any later manipulations or extractions performed in the code. In this example, we access the last character of a string by using a negative index. In Python, negative indexing lets you count positions from the end of the string instead of the beginning. An index of -1 refers to the final character. This is useful when you want to get elements from the end without first computing the length of the string. In this example, we access the last character of a file name by using the string's length. We find how many characters are in the string, then subtract 1 to get the index of the final character. This method is equivalent to using a negative index, but it relies on a positive index instead. It shows that both approaches give the same result, offering flexibility in how you access characters in a string. This example shows that using a negative index of -1 to access a string returns the same last character as using the corresponding positive index. The -1 index refers directly to the final position in the string. This demonstrates that negative indexing is a convenient way to access elements from the end of a sequence without first calculating its length. In this example, we print the last character of a file name using a positive index. We do this by taking the length of the file name and subtracting 1 to get the index of the final character. This approach gives the same result as using a negative index. It shows that Python lets you access characters from the end of a string in more than one way, highlighting the flexibility of its indexing system. In this example, we take the last 3 characters of a file name by using a negative starting position in the slice. A start value of -3 tells Python to begin 3 characters from the end and go to the end of the string. This is a convenient way to grab the file extension or any other ending part of the name without first computing how long the string is. We take the last 3 characters of the file name to get its extension. This quickly tells us what type of file it is, such as a text, image, or other format. Doing this avoids the need to manually count characters from the end of the name each time. In this example, we remove a file extension by slicing the file name string to drop the last 4 characters, using a negative stop index of -4. The shortened result is stored in a variable that represents the file name without its extension. This approach leaves only the main part of the file name and is a concise way to manipulate strings when you know exactly how many characters to remove from the end. This line of code prints the file name without its extension by storing a shortened version of the name in a variable. It removes the last 4 characters, which usually represent the file extension. By using a negative index to slice off these characters, the code efficiently strips the extension and shows a practical use of slicing in Python. In this example, we take the file name and slice out the last 6 characters by using a negative index of 6, which counts backward from the end of the string. This lets us quickly grab a specific ending portion of the text, such as a file extension or other trailing details. The key idea is that negative indexing avoids having to calculate the total length of the string before accessing its final part. This example uses negative indexing to print the last 6 characters of a file name. It shows how you can easily access part of a string starting from the end. This approach is especially helpful for getting file extensions or similar ending segments. You can do this without first calculating how long the string is. This script shows how negative indexing in Python lets you access characters from the end of a string. It first prints the full file name, then compares getting the last character using a negative index with using the string length, demonstrating they give the same result. It then uses negative slices to grab the last 3 characters as a file extension. Remove the extension by excluding the last 4 characters, and slice the last 6 characters for extra practice. Overall, it highlights how negative indexing makes string operations more convenient and readable. Basic string slices. After learning how to identify characters by their positions, the next step is to work with slices, which are segments of text taken from a larger string. To create the slice, you specify where it starts and where it stops, and the language returns the characters in between as a new string. This is useful for pulling out specific parts of a longer piece of text, such as a first name from a full name or a domain from an email address. You can think of it as placing markers between characters and selecting everything between 2 markers to form the slice. When you create a basic slice, you choose a starting and an ending position, and the slice includes the character at the start but stops just before the end. This rule, called including the start and excluding the stop, can feel unusual at first but has important advantages. It makes it easy to calculate the length of the slice and helps different slices line up exactly without overlapping or leaving gaps. For example, you can take one slice for the first part of a sentence and another slice for the next part, and they will fit together seamlessly. When slicing strings, you can leave out the start or end positions to make common tasks easier. If you skip the start, the slice begins at the first character and stops just before the position you specify, which is useful for taking the beginning part of a piece of text. If you skip the end, the slice starts where you choose and continues to the end of the string, which helps when you need everything after a certain point. Leaving out both the start and end simply gives you a full copy of the entire string without changing the original. Python code, basic string slices. In this lesson, we focus on basic string slicing using simple greeting words. You will see how to select parts of the string by clearly choosing start and stop positions. You will also practice leaving out the start or end position to create more flexible slices. Together, these examples show how to extract different portions of a greeting using straightforward slicing rules. This line in the script is a placeholder for installing any required libraries before the code runs. Including such a line at the start is a common way to make sure all dependencies are available. In this particular script, no specific library is listed, which means the current code does not actually depend on any external packages. We begin by creating a text value that says hello from New York City, which will serve as our main example. This single piece of text lets us clearly demonstrate how slicing works in Python. Using it, we can show how to access and manipulate different parts of a string. This setup provides a simple, consistent base for exploring various slicing techniques. First, we print the entire greeting string to the console so we can see its original form. This step lets us verify the content before we start slicing or modifying it. Confirming the initial state of the data is a good habit when working with string manipulations because it helps you understand and trust the changes you make. We take the greeting text and slice out its first 5 characters by specifying positions 0 through 4. This slice operation extracts the substring hello from the original text. We then store this substring in a variable called firstPart so it can be used later for display or further processing. We display the first slice of the greeting text, which contains only the first 5 characters. This slice was stored earlier in a separate variable. By printing it, we can see the beginning part of the original string. This simple example helps demonstrate how string slicing works in Python. In this example, we take a slice of the text stored in the greeting by selecting characters from position 6 up to but not including position 11. This operation extracts the word from, followed by a space and the letter N, isolating just that segment of the original string. String slicing like this is useful when you know the exact character positions of the part you want to retrieve. The code takes a slice of the original string, selecting the characters from positions 6 through 10, and stores this slice in a variable. When that variable is printed, it shows only this selected portion of the string. This lets you view just the characters that fall within that specific range of the original text. In this example, we slice a string from the beginning up to the 11th position. which gives us all characters from the start through the one at index 10. Because string indexing starts at 0 and the stop position in slicing is not included, the character at position 11 is left out. This approach is useful when you want a specific initial portion of a string without explicitly giving a starting index. It helps keep the code simpler and more flexible. This example shows how to take a slice of a string from the beginning up to position 11. When you leave out the starting index, the slice automatically begins at the first character. This makes it easy to grab the initial part of a string without extra typing. As a result, your code becomes more concise and flexible while still clearly expressing which portion of the string you want. In this example, we take a substring starting at position 11 and continue to the end of the original string. We do this by giving Python a starting index of 11 and leaving the ending index unspecified. Leaving the end blank tells Python to keep slicing until it reaches the string's end. This approach is useful when you want everything from a certain position onward without needing to know how long the string is. This line takes the greeting text and returns a substring that starts at position 11 and goes all the way to the end. By leaving out the ending position, it automatically includes every character from the starting point through the last character. This is useful when you want everything from a certain index onward without needing to know or calculate the string's exact length. In this example, we create a full copy of a string by using slicing without specifying start or end positions. This tells the program to take the entire string from beginning to end. The result is a new variable that contains exactly the same text as the original. It is a simple way to duplicate a string while keeping the content unchanged. Using slicing without specifying a start or end position creates a complete copy of the original string. This means the entire string is duplicated through slicing alone. It shows that slicing can replicate a string exactly without changing any of its content. This example shows how basic string slicing works using a greeting message. It first prints the full text, then slices out the first 5 characters, and then a middle section to get the word from. It also demonstrates slicing from the start up to a certain position, slicing from a position to the end, and finally making a complete copy of the string using slicing. Together, these steps illustrate how you can efficiently extract different parts of a string by choosing start and end positions, or by leaving one of them unspecified. Essential string methods. Changing case. Changing the case of text is a basic but important operation when working with strings. It lets you convert text to lowercase, uppercase, or mixed case so that data is cleaned and presented consistently. This is especially useful when handling user input or preparing data for analysis. For example, converting all email addresses to lowercase helps avoid errors, since email systems treat addresses as case-insensitive. Overall, case conversion ensures that strings that look different, such as all caps versus all lowercase, are treated as the same when they represent the same information. Case conversion is important for displaying text consistently in reports, user interfaces, and automated messages. It lets you control whether headlines appear in uppercase, names use only initial capitals, or sentences start with a capital letter. In systems like customer relationship management tools, names may be entered in many different formats, so standardizing them to a conventional form, such as turning Alexander Smith or Alexander Smith into Alexander Smith, improves readability and professionalism. This consistency also shows respect by presenting people's names in a clear and familiar way. When working with large text collections, converting all text to the same case is important for reliable comparison, grouping, and searching. Differences in capitalization can cause matches to fail, so standardizing case makes these operations case-insensitive. This is especially useful when matching categories, filtering logs, aggregating survey responses, and counting words, because it treats variations like data and data as the same. Overall, changing case improves the consistency, robustness, and fairness of text processing. Python code, changing case. This lesson introduces basic ways to change the letter case of text in Python so beginners can handle strings consistently. You will see how to convert text to all lowercase, all uppercase, and title case, where each word starts with a capital letter. Simple examples will show how the same word or phrase can be normalized to a standard form, which makes it easier to compare, search, and process text reliably. This line in a script is a placeholder for installing any needed libraries. Programmers often include such a line at the start of a script to make sure all dependencies are available. In this case, the line is commented out, which shows that no extra libraries are required. The script only relies on Python's built-in features for working with strings, so additional installations are not necessary. We use a text value containing the name Alexander Smith with mixed capitalization to demonstrate how string case transformations work. From this starting point, we can convert the text to all lowercase, all uppercase, or title case. These operations are useful for normalizing text data so that names and other words follow a consistent style. This code takes a text value that holds a name with mixed capitalization and converts all its letters to lowercase using a built-in method. Doing this normalizes the text so that the capitalization is consistent. This is especially helpful when comparing names or storing them in a database, because it reduces errors caused by different capitalizations of the same text. We have a text value that stores a name with mixed capitalization, and we want to convert it to all uppercase letters. To do this, we call a built-in method that changes every character in the text to its uppercase form. The result is a consistent all-caps version of the name. This is useful when you need a standardized way to display names or other text. The code takes a text value representing a name and converts it to title case. In title case, each word starts with a capital letter and the remaining letters are lowercase. This helps keep names or titles formatted in a clear and consistent way. The transformed text is then stored in a new variable for later use or display. We first print the original name string so we have a clear starting point for comparison. This baseline makes it easier to see how the string changes when different case transformations are applied. By comparing the original with each transformed version, we can clearly observe the effects of these operations on the text. This code converts a name to all lowercase letters to normalize the text. Converting to lowercase makes the text consistent, which is especially helpful when comparing names or storing them in a database. By standardizing the case, it reduces errors that can occur when the same text appears with different capitalization. In this example, we convert the name text to all uppercase and then print it. Turning text into uppercase can give it a shouting effect, which is often used for emphasis or style. The transformed version is stored separately, so we can print it and compare how it looks next to the original and other text case formats. This code converts a name string into title case, where each word begins with a capital letter followed by lowercase letters. Using title case helps standardize and clean up mixed capitalization in the original input. It is especially useful for formatting proper names so they look more formal and easier to read. The program then displays the title-cased version to show the effect of this transformation on the original text. In this example, we create a text value that holds an email address written with inconsistent capitalization. This setup is used to show how text normalization can convert the address to a consistent form. Normalizing email text is important so that email addresses are handled reliably, especially when they are compared or stored in a database. The code converts the email address stored in a variable to all lowercase letters to ensure consistent handling of the text. It does this using a method that changes every character to lowercase. This is useful for normalizing email addresses so that differences in letter case do not cause problems when comparing or storing them. We first display the original email address so we have a clear reference before making any changes. This allows us to compare the email before and after normalization. By doing this, we can easily see how changing the letter case affects the appearance of the email text. This code prints a normalized version of an email address by converting it to lowercase. Doing this ensures the email is handled consistently, which is important when comparisons should ignore letter case. By showing the original and the normalized result, it illustrates how case normalization is a key step in reliable text processing. This material explains how to change the case of text in Python by converting strings to lowercase, uppercase, and title case. It uses a name with mixed capitalization to show how each transformation changes the appearance of the text, and prints the original and converted versions for comparison. It also demonstrates normalizing an email address to lowercase to support case-insensitive comparisons. Overall, the focus is on how case conversion helps keep text consistent and easier to process. Trimming spaces. Extra spaces in text, especially at the beginning or end, can cause subtle errors in programs. They often appear through user input, copy-pasting, or data exports from tools like spreadsheets. Most programming languages provide string functions to remove these spaces from the start, the end, or both, while keeping the main content unchanged. This trimming is important for comparing text, checking whether a field is truly empty, and preparing data for storage. Because even invisible spaces can make two strings that look the same appear different to a computer. Trimming extra spaces from text is important when handling real-world data, especially user input and imported records. Extra spaces in things like course codes, discount codes, or email addresses can cause valid entries to be rejected, messages to fail, or duplicates to be missed because the text no longer matches exactly. By consistently removing leading and trailing spaces before checking or storing data, you make your programs more reliable and easier for users to interact with. When working with strings, you need a clear strategy for handling whitespace, not just at the edges but also inside the text. In some tasks, such as cleaning names, you may want to collapse multiple spaces into a single space for consistency. In others, like processing log files, it is important to keep internal spaces exactly as they are while trimming only the ends. In certain cases, such as normalizing identifiers, you might remove all white space, including tabs and line breaks. Choosing the right trimming approach directly affects the accuracy and reliability of your system. Python code: trimming spaces. This content focuses on cleaning user text input by trimming unnecessary spaces. It explains that you should remove extra white space at the beginning and end of a string so the stored value is clean and consistent. You compare the original raw input with the cleaned version to see the difference. To do this, you use string methods that strip leading and trailing white space from the text. This line in the script is simply a placeholder to remind you to install any libraries the code might need. In this particular script, no external libraries are actually required, so nothing needs to be installed. However, including such a reminder is common when sharing code, especially if the script may later be expanded to use additional features that depend on external packages. We begin with a text value that represents the code save10, but it has extra spaces on both sides. This setup imitates real user input, which often includes unwanted spaces or slightly messy formatting. Using this example, we can focus on how to properly handle and clean the input so that we extract just the meaningful text. This prepares us to process user-entered codes or similar data more reliably in real applications. We begin by printing the raw input text to the console with square brackets around it, so that any extra spaces become clearly visible. This makes it easy to see exactly where spaces appear in the original text. By doing this first, we can later compare the raw version with cleaned versions and clearly observe how the text has changed. This code works with a text value that has extra spaces at the beginning and end and uses a strip method to remove them. By doing this, it cleans up the input so that only the meaningful content of the text remains. This is especially useful when handling user input where unwanted spaces are common. The result is a neater, more accurate string for further processing. In this example, we focus on removing spaces only from the left side of a string. We start with a string that has extra spaces at both the beginning and the end. To clean up just the left side, we use a method called leftStrip, which removes any leading white space while leaving the rest of the string unchanged. This is helpful when you want to keep spaces on the right, but need a tidy start to the string for later processing or comparison. This code uses a method that removes spaces from the right end of the text stored in the input variable. It is helpful for cleaning up user input by getting rid of unnecessary spaces at the end. This makes the text neater and ensures it is correctly formatted for later processing or comparison. This line displays the string after removing spaces from both ends. It adds markers around the clean text so you can clearly see what remains. By comparing the marked result with the original, you can visually confirm that the extra spaces have been successfully trimmed. We show the result of removing spaces from the left side of a string. The print function outputs the text announcing the left strip result, followed by the clean string placed inside square brackets. Using brackets makes it easier to see exactly how the leading spaces have been removed. This clearly demonstrates the effect of the left strip operation on the original text. We use the right strip method to remove only the spaces at the end of a string, trimming any trailing white space while leaving the rest of the text unchanged. After cleaning the string, we display it with markers that highlight where the text ends. This makes it easy to see that there are no spaces remaining on the right side and to compare the cleaned version with the original input. This code checks whether the user's input after removing any spaces at the beginning and end matches the text Save 10. By trimming the input first, it focuses only on the meaningful characters and ignores accidental extra spaces. This makes the comparison more reliable for validating user input against the expected value. This script shows how to remove extra spaces from a string in Python using different strip methods. It starts with a promotional code that has unwanted spaces around it, then prints the original version with markers so you can hear where the spaces are. Next, it demonstrates trimming spaces from both ends, only the left side and only the right side, and prints each result with markers to make the changes clear. Finally, it checks whether the fully trimmed string matches the expected code Save 10, confirming that the strip method successfully cleans up the white space. This is a simple example of how to prepare user input or text data by removing unnecessary spaces. Searching within strings. Searching within text is an essential operation for tasks like checking whether a message contains a certain word or finding where a phrase appears. In practice, this might mean seeing if an email subject includes the word urgent or if a web address begins with a secure prefix. String search operations systematically scan text to locate target sequences, much like sliding a window along the string and checking for matches at each position. Modern programming languages provide efficient, built-in tools for this, so you can focus on what you want to find rather than how the search is carried out. In programming, different search methods help you check whether a string contains a specific substring or find exactly where it appears. Some methods only tell you yes or no, which is useful for tasks like filtering content or validating data. Other methods return the position of the substring, often as an index, so you can extract or modify parts of the text, such as pulling out a file name from a longer path. Understanding which type of result you need helps you choose the right search method for your task. Search methods are essential for advanced text processing because they help analyze user input and parse data. They allow applications like survey tools to categorize feedback and chatbots to detect urgency in messages. User interfaces also rely on search to highlight words and refine results as you type. Combined with other string operations, such as changing letter case or trimming spaces, These techniques turn raw text into structured, useful information. Python code: searching within strings. In this lesson, we will explore simple ways to search within strings and clearly display the results. You will see how to check whether a shorter piece of text is contained in a longer message and how to find its position. We will also combine searching with slicing so you can extract useful parts of a message based on where they appear. No external libraries are needed, making this a beginner-friendly introduction to basic string searching. We begin by creating a variable that stores a sample email subject line. Set to the text urgent, meeting moved to 3 p.m. tomorrow. This gives us a concrete piece of text to work with. We will use this subject line to practice how to search within and manipulate strings in Python. The focus is on using this example as a simple, consistent test case for string operations. The code converts the email subject line to all lowercase letters so that searches do not depend on capitalization. By standardizing the text in this way, the program can match words whether they were originally written in uppercase, lowercase, or a mix of both. This makes case-insensitive searching simpler and more reliable. The code checks whether the word urgent appears anywhere in the subject line. It does this by converting the subject line to lowercase so that capitalization differences do not matter. This way, it can detect urgent whether it is written in all caps, all lowercase, or any mix. The result is stored as a value that indicates if urgent was found or not. This code checks whether the word urgent appears in the subject line and then reports the result. It first converts the subject line to lowercase and uses a true or false value to represent whether urgent is present. Finally, it prints a clear, human-readable message that shows the outcome of this search. To locate where the word meeting appears in a subject line, we first convert the subject to lowercase and then use a search method to look for the substring meeting. This method returns the index where the word meeting begins in the text. If the word is not present, it returns -1. This index tells us the exact position of meeting in the subject, which can then be used for further processing or extraction. This code finds where the word meeting begins in the subject line and prints that starting position. If the word is not present, it returns -1. This allows you to know the exact location of the word in the text, which can then be used for additional processing or checks. We use the index we found earlier to slice the subject line, starting at the word meeting and continuing to the end of the text. This lets us pull out the full phrase that begins with meeting. Extracting this segment can then be useful for any later processing or analysis steps. We use the index where the word meeting was found to slice the original subject line from that word to the end. This creates a shorter phrase that begins with meeting and includes all remaining text in the subject. We then display this extracted substring to show only the relevant part of the subject line. We create a log message that repeats the phrase "access denied" several times to demonstrate how to count how often a specific phrase appears in a longer string. This simple example models real log files where the same error or security alert may occur repeatedly. By counting these repeated phrases, we can better analyze logs for patterns of errors or potential security issues. To count how many times the phrase access denied appears in a log message, first convert the entire log to lowercase so the search is not affected by capitalization. Then use a counting method to find how often the phrase access denied occurs in this lowercase text. This simple approach reliably tallies all instances of the phrase in the log data. This code counts how many times the phrase access denied appears in a log message. It first converts the entire log message to lowercase so that differences in capitalization do not affect the search. It then uses a counting operation to find all occurrences of the phrase. Finally, it prints a clear message showing the total number of times access denied was found. This script shows basic string searching in text. It checks whether the word urgent appears in an email subject line by converting the text to lowercase for a case-insensitive search. It then finds where the word meeting starts in the subject and extracts the rest of the phrase from that point. The script also counts how many times the phrase access denied appears in a log message. When run, it prints whether urgent was found, the position of meeting, the extracted meeting phrase, and the number of access denied occurrences, illustrating simple string manipulation without extra libraries. Building string messages. String concatenation basics. In programming, you often create readable messages by joining several pieces of text into one longer string. This lets you mix fixed phrases with changing values, such as user input or data from a system. For example, you might combine a greeting, a person's name, and a date into a single message. By choosing the right order and adding spaces and punctuation, you turn raw data into clear, natural language similar to everyday writing. When you join pieces of text together, focus on readability and smooth flow, not just on combining parts. Missing spaces or punctuation can turn your output into a confusing jumble. Instead, think in terms of complete sentences and decide where spaces, commas, or dashes belong so the message is clear. Treat concatenation as a writing task where you craft clear communication from dynamic pieces at runtime. Concatenation is the process of joining text and variable values to create clear, tailored messages for different audiences. It can be used in learning systems to personalize messages with a student's name, course, and grade, or in business tools to build confirmation messages with order details. Data analysis tools also use concatenated text to label charts and summarize results. The key idea is to combine these elements in a deliberate order so the final message is coherent and easy for people to understand. Python code, string concatenation basics. This section focuses on basic string concatenation to create clear, personalized messages. You will learn how to combine fixed text with changing values stored in variables, so the final message is easy to read. Attention is given to adding spaces and punctuation in the right places so the output sounds friendly and natural. The goal is to build complete, readable sentences from separate pieces of text and data. This line is simply a placeholder comment reminding you that, in some scripts, you might need to install extra libraries using a package manager. In this particular script, only Python's standard libraries are used, so no additional installation is required. It is there as a general reminder for cases where external libraries are needed, but here everything works with the built-in Python tools. We first store the user's name, Alex, in a variable so we can personalize messages. Then we store a description of what the user has done, which is completing their daily walking goal, so we can clearly state the achievement. We also store the distance walked as the string value 3. Keeping this distance as a string makes it easier to join with other text when building a full sentence for the user. We build 2 messages using string concatenation so they can include changing information. First, we create a personalized greeting by joining the word hello with the user's name and an exclamation mark. Then, we form a progress message by combining the phrase you have with the action the user completed and the distance walked, ending with the word miles. This approach lets us dynamically insert user-specific details into clear, readable output. We combine the greeting message and the progress message into one complete sentence by joining them with a space so it reads clearly. This process is called concatenation. After forming this combined message, we print it to the console. The result is a single personalized message that includes both the greeting and the progress update. This script shows how to use basic string concatenation to build a personalized message. It sets up a user's name, an action they have completed, and a distance walked, then combines these pieces into a greeting and a progress update. These parts are joined into one final sentence that acknowledges the user's achievement, such as completing a daily walking goal. Overall, it demonstrates how to mix fixed text with changing values to create clear, engaging output. Formatted string basics. Formatted strings let you write a message once and mark places where changing values, such as names or dates, will be inserted. This makes it easy to create messages that share the same structure but contain different details, like order confirmations with customer information. By separating the fixed text from the dynamic data, your code stays cleaner and the output remains consistent and easy to read. Formatted strings help you smoothly combine different kinds of data, like numbers and dates, into clear, natural messages. They let you control how values are displayed, such as forcing prices to show 2 decimal places or adding separators to large numbers. This is useful whether you are rounding, scientific measurements, or aligning text in business reports. Overall, formatted strings keep your code tidy and your output professional by tightly connecting your program's logic with how results are presented. As your applications grow more complex, formatted strings become essential for clear communication. They help create polished status updates and error messages, and they make data analysis results easier for non-technical stakeholders to understand. In multilingual contexts, formatted strings also work with translation tools so that only the language changes, while the underlying values stay correctly formatted. Mastering formatted strings lets you deliver messages that are accurate, professional, and tailored to your audience, which is a key skill in modern computing. Python code, formatted string basics. This section explains how to use formatted strings to combine fixed text with values that can change. The goal is to show that you can write one message template and reuse it with different variable values. By plugging in new values, the same basic sentence can display different information. The focus is on keeping the output short, clear, and easy for beginners to read and understand. This line is simply a placeholder comment indicating where you would add a command to install any required libraries for the script. It serves as a reminder to make sure all needed dependencies are installed before running the code. In this particular script, no external libraries are actually used, so the comment is mainly about following good practice when preparing your environment. In this example, we set up basic information for an online order by defining a customer name, Alex, an item name, a wireless mouse, the item price as $24.5, and the shipping time as 3 days. Together, these values provide the key details needed to create a simple order summary in an online store. We use a formatted string to build a confirmation message that includes the customer's name, the item they bought, and the price. This lets us embed values directly inside the text, so the message updates automatically for different customers, items, and amounts. The price is formatted to 2 decimal places, so it looks like a standard currency value. Overall, this makes the confirmation message clear, professional, and easy to reuse in many situations. In this example, we create a message that tells the customer how long delivery will take. We use a formatted string, so the number of shipping days is inserted automatically into the text. This makes it easy to change the delivery time in one place while keeping the message accurate. It also helps keep the message personalized and clear for the customer. The code prints 2 lines to form a clear order summary. First, it shows a confirmation that thanks the customer by name and states the item and its price. Then, it prints a delivery message with the estimated delivery time. Together, these lines give the user a complete and easy-to-understand overview of the order. This script shows how to use formatted strings to create a clear order confirmation message for an online store. It sets up information such as the customer's name, the item, its price, and the estimated shipping time, then uses these values to build 2 messages. The first message thanks the customer and states the item and its price, with the price formatted to 2 decimal places. The second message gives the estimated delivery time. When run, the script prints both messages, providing a simple, professional confirmation that can be easily reused for different orders by changing the stored values. Joining list items. When generating richer text output, it is often necessary to combine multiple values into a single clear phrase. Instead of listing items separately, you might want a sentence like saying you will cover data types, control flow, and functions. This means joining pieces of text with separators such as commas or the word and so the result sounds natural. Being able to turn raw data into readable, human-friendly language is especially important in dashboards, reports, and similar applications where clarity and tone matter as much as correctness. When you join items into a sentence, the separators you use affect how natural the result sounds. Simple commas may be fine for machine output, but for people, you usually need spaces and a linking word before the last item such as the word and. This means you must combine basic string operations with an understanding of language conventions, like how commas work in lists. For example, two names might be joined as Alex and Priya, while three names become Alex, Priya, and Jordan. Effective joining therefore depends on both technical formatting and attention to grammar and style. Combining list items with other string techniques lets you turn structured data into natural, context-aware messages. For example, a travel app can convert a list of destinations into a friendly sentence that describes where the user will visit. This same pattern applies in many areas, such as learning platforms or health apps, where data is joined with separators and embedded into larger messages. By practicing this approach, you can transform raw lists into conversational output that feels more personalized and less mechanical for users. Python code, joining list items. This material explains how to turn a list of items into a clear, readable message. It shows how to join items with commas and then add a more natural connector, such as a word that links the last two items. The focus is on creating human-friendly strings rather than raw list output. Finally, it demonstrates printing complete messages that combine these joined lists with other pieces of information. The commented line with the exclamation mark and the install command is simply a placeholder for adding any library installations the script might need in the future. Such lines are often placed at the top of a script to make sure all dependencies are installed before the code runs. In this particular script, it is commented out, which means no extra libraries are currently required. It mainly serves as a reminder or template if the script later depends on external packages. We begin by creating a list of course topics that includes data types, control flow, and functions, which represent the subjects for today's session. Grouping these subjects into a single list makes it easier to manage them within the script. This structure allows us to adjust, reorder, and format the topics later for different kinds of output. We combine the list of course topics into one string separated by commas to create a more compact format. This makes the information easier for a computer to process or store in logs. Using the join operation on the list simply connects each topic with a comma in between. The result is a single, streamlined text representation of all the topics. Iscode prints a compact message listing the course topics. It stores the topics in a single string where they are joined by commas with no spaces. This tightly packed format is efficient for computers to process and is useful when space is limited. By removing extra white space, it keeps the information clear while minimizing the amount of text. We combine a list of course topics into one readable string by placing a comma and a space between each item. This is done using a join method that links all the list elements together. The result is a single, clear line of text where each topic is separated by a comma and a space. This makes the list easier to read and present in a sentence or message. We build a complete sentence by placing the readable list of topics into a larger string. This uses a formatted string to insert the combined topics directly into the sentence. The result clearly tells the learner what will be covered today. It also provides a friendly and engaging introduction to the session. The code prints a friendly message that summarizes the course topics for the learner. It builds this message using a formatted string that turns the list of topics into natural, readable text. The final result is a clear, engaging sentence that tells the user what will be covered today. We begin by creating a list of cart items that includes a laptop, a wireless mouse, and a backpack. This list represents the contents of a shopping cart. It will be used in later steps to combine these items into a single, readable sentence. To create a natural-sounding list in a sentence, we first take all the items except the last one. We then join these items into a single string using commas and spaces between them. This produces a clear, readable list that fits smoothly into normal speech. It also prepares us to add the final item with the word "and," which is how lists are typically spoken in everyday language. To create a natural-sounding sentence that lists items in a shopping cart, you build a single string that describes the cart's contents. You first include all items except the last one, separated by commas. Then you add a comma, followed by the word "and finally, the last item. This structure matches how people naturally list things in conversation, which makes the result clearer and easier to understand. The code generates a summary sentence that describes what is in a shopping cart. It builds this sentence so it sounds natural in everyday language. All items except the last are separated by commas and spaces, and the word "and" is added before the final item. This structure makes the output easier to read and more conversational for the user. This script shows how to turn lists into readable text messages. It first joins a list of course topics with commas to create a compact format, then adjusts the spacing to sound more natural and uses it in a sentence about what is covered today. It then applies a similar idea to a shopping cart, joining all but the last item with commas and adding the word "and" before the final item for a conversational tone. Overall, it demonstrates how to format lists differently depending on whether the output is meant for technical use or for human-friendly narration. In this lecture, you learn to access and slice substrings using string indexing and slicing syntax. Use common string methods to change case, strip whitespace, and search within text. And combine strings and variables to build readable messages. In the next lecture, Lecture B, we will go over simple text parsing.
Thank you for your attention. See you all in the next lecture.